Hi, I'm Rahul, and in this tutorial, I would like to show you how you can search for useful packages for your data manipulations or modeling. It's often quite painful to search a proper package for your data analysis. Going through the CRAN manual is looking for different packages is quite painful because you don't know whether this package is useful or you're able to use that. And there are two ways for searching packages. One is such directly going to CRAN website and manually looking for different packages, and another is you can go to the meta CRAN of rpackage.org website where you can get the popular packages, different downloads, how they get updated, and another uh, uh, by using a package or R package to find out what are the different packages available or what is their popularity. So the package finder is a package that you can use for searching different R packages based on your requirement. So this first published in our community blog by Joseph Rickard in RStudio community blog, where he has shown how you step by step use this package finder for finding useful packages. So to show you, I'm going to use this library package finder for finding package, and tidyverse. This package is basically to find the packages, and along with I'm going to use this tidyverse for data manipulation plotting, and dlstat package then to identify the number of downloads per package per month, and the CRAN lead to track such authors network, how authors are collaborating with other authors to identify their popularity. So based on popularity also you can, along with such a different number of downloads or total downloads, you can also identify the network size such to identify whether the author is popular or not, who has such a provided particular or who has created a particular package. So you have to install these packages, package finder, tidyverse, dlstat, and cranly. And after that, you have to just say we want to, well, starting with this package finder, say we want to identify different packages that can help us model random forest. So the keyword would be random forest here. And to identify different packages from the CRAN, uh, so you have to use the find package function inside that in quotation give the random forest. And I'm saving it as .tibble so that it would look such a better and organized. And I'm saving in rf underscore package. It will take time, just run, and it will fetch the data from CRAN of the different package data that uh, comes that helps in modeling random forest. Another thing is to don't forget to load those packages, otherwise this function won't work. This package finder tidyverse, this package finder first of all, and then for other uh, data manipulation, this tidyverse, dlstat, and cranly. So now we can see that rf underscore package, this the random forest related data uh, is retrieved from the server and saved inside this rf underscore package, and it contains 82 observations and 5 variables. And if you want to see the names, use or column names, use the names function and supply the object inside that. And you can see it has 5 columns: score, name, this short, down total or download total, and go. And if you see using the head function of, or take a glimpse of the first 6 rows, then use the head function, you can see the score, name, this short, and download total, and go. So next, we are going to identify download per package per month using CRAN underscore stats function from dlstat package, this dlstat package. And we are storing this in whatever the object will get. I'm storing this in package underscore downloads. So use the CRAN underscore stats function, and inside that supply the rf underscore package where we have saved those packages, and with dollar select the name column. So here is the names. So based on these names or this different package names, it will retrieve the stats of those packages, that what is the different number of downloads per month, start of the download or end of the download, time, date, time, those things would be there inside the data. So use the CRAN underscore stats function inside give this rf underscore package, and with dollar select the names so that it will get the stats of those such a package names, and saving this in package underscore downloads. It will take some time, so just run and it will retrieve the data. So now it has retrieved, and you can see the dimensions using the dim function. So 3428 observations and 4 columns. So if you see using the head function, you can see the first 6 rows that contains the package fuzzy forest and downloads. This is the start date, like 2016's month 2 and day 1 to month 2 and day 29 end. So 18 downloads. And again on the next month there are 172 downloads, and so on. So it contains stats of every month, how many downloads for a particular package. So using the dplwire verb or dplwire package from or using the tidyverse package, you can directly import the dplwire and sort this one, that how many total downloads such per package, overall total download, and we will sort that in descending order. So we are taking this package underscore downloads object where we have saved our different stats, and with pipe operator we are supplying this to with pipe operator. Next we are using the group by function to group the data based on the packages. So under each package the data will be segregated, and after that we are using the summarize function with the pipe operator and creating a new column downloads where the sum of the downloads will store, or we are overriding the downloads actually where the sum of the downloads will store. And after that we are arranging in the descending order this download column. If you run this function and use the head function to see, you can see the most downloaded package is random forest with around 2.1 million downloads. So it is one of the most popular packages. So next, if you want to plot or see how the trends of this top 3 package, how this time series data looks like from say 2013 or 14 to 2018 or today when I am downloading this data. So you can do that using this just supply the object package downloads where we have saved based on different package names the CRAN stat, and with pipe operator use the filter function, and inside that package percentage in percentage inside package just try to match the most underscore downloaded this data with this data dollar package and first top 3. So actually what we are filtering here, we are taking this package underscore download data here where the CRAN stats are stored, and inside that we are trying to match what are the packages we want to retrieve the information of the stats of the top 3 packages from that data where we have stored the end time and start time and its downloads. Okay, so it will fetch this such a stats of this top 3 packages that we have stored in descending order in the most underscore downloaded. So if you run this and see the top 3 packages or use the head function, that would be much better. Top 3 packages. Now you can see random forest package over from 2012 onward, like from month 10, month 11, 12, and 2013 month 1, month 2, month 3, and so on. So it has data for 3 popular packages or 3 top packages. Now if you use the ggplot and supply this inside the data, the top 3 packages, and inside the mapping in aesthetic x is equal to end, y is equal to downloads, or that is the downloads, and group equal to package, so you'll group the lines based on the packages, and color package, and plus use a geom, that is such a geometry geom underscore line function, and plus geom underscore point, so it will also show the point in the plot, and mapping is equal to aesthetic and shape is equal to package, so the point shape will be based on package and size is 2. If you run this it will show the trend how from 2012 onwards, such as it up to 2018 today, how the downloads fluctuating actually, or fluctuates. So you can see the random forest downloads has significantly dropped here in 2000 last, or say in November or October and November. And after that, the second popular package is Party, and third popular package is H2. How the trend is going on, or downloading trend is going on 2012 onward. It is based on the number of downloads, how popular the packages are. So maybe you'll use this random forest package for your random forest modeling because it is quite popular. Another way of looking that which package is quite popular is to look into the author's network, how collaborative this the author is actually, how much packages he has been developing, or how much package he has developed. So and what are the collaborative network, how much collaborative he is, and with how much other collaborator he is collaborating. You can also fetch that data from the CRAN. So to do that, say here the most popular package is random forest. So I'm using the citation function to identify who is the author, and here is the author is Andrew Liu, and we will try to plot his or collaborative network, that how he is collaborating. So to do that, I'm using this CRANly package. We have already loaded this CRANly package, and with the tools package that helps us to fetch the data or obtain information about current packages in the CRAN package repository and their check status. And we are using the CRAN underscore package underscore dv function to retrieve the data from the CRAN and saving in p underscore dv. So just save this one. It will take some time. Just keep patience. And it downloaded. After that, you have to just clean that data using clean underscore CRAN underscore dv and supplying this object and saving in clean underscore p underscore dv. And once you do that, it will take some time. Yeah, now it's done. So now use the build underscore network function. Inside that object, give this clean data, clean underscore p underscore db with comma, prospective is equal to author. So we want to build the network based on authors, and saving in author underscore net. And after saving this, just you want to see how the networks look like. So use the plot function, and it will take some time to save. Now use the plot function, and inside that give the author underscore net with comma author equal to Andrew Liu, because we want to retrieve his collaborative network, and with comma extract equal to exact equal to true. So exactly his network will be plotted in the plot area. So if you press Ctrl Enter, it will plot the network, and now you can see based on 10 November 2018, and this is the time 5:08 p.m. right now, or 17:08 p.m. you can say. So here is the Andrew Liu selection network. And again, if you want to see who are the say top 20 or top 25 popular author or popular package holder, so you can use the summary function, and inside that supply this author underscore net and saving inside author underscore summary. And once it's saved, you can use direct the plot function and supply that object inside that. It will take some time. Still computing. And now you can use the plot and supply this object and press Ctrl Enter or run that code. You can see that based on currently top 20 according to n underscore packages. Package database as of 28/11/10, today's date, and the time here it is. And the hardly Wickham is the most popular with more than 125 or 128 package or 130 packages. And you can see the most top 20 popular package holders. So this is the ways you can identify different packages or look for a different package and do your analysis rather than just manually looking into the CRAN website. So if you like that video, just share, and thanks for watching. And thanks to the author for publishing step-by-step guide in how we can find better packages using Package Finder. And thank you for watching.